How many times? Well, you identify, number one, que this belongs to the family of the x squared. Es separable. Actually, es separable. This is separable. But you identify the order of operation here of the transformation. So I can see, wow, the first transformation is this. It's operation inside the parenthesis, no? So this is the first transformation that we are doing is x minus 5 square. Okay, this is horizontal shift. Okay, remember is when it's inside the parenthesis horizontal shift. 5 unit to the right, no? Because remember it's completely opposite. When it's negative right, when it's positive left. Okay, super. Now the third transformation, because we have third, no. The second transformation is minus x minus 5 squared. Basically, this is, well, actually, the thing we are doing is multiplication by -1 here, huh? -1 is invisible, ¿no? Entonces es la que sí es -1. Entonces we have reflection. Reflection about x-axis. So in this case, look, this is my parabola, my original parabola. This now, in the second, this is my new parabola, 1, 2, 3, 4, 5. Okay, 5 units to the right. Now, in the third step is reflection, to say 1, 2, 3, 4, 5. My parabola is going down now because it's negative reflection. Number 4, finally, is +3. And +3, okay, one is minus x minus 5 squared +3 is a vertical shift 3 unit up. Okay, so my last answer is 1, 2, 3, 4, 5 down, pero 3 unit up. 1, 2, 3. I suppose that the vertex is a very good point to make a reference of the parabola is now located in phi 3 here. And this parabola is going down. Something like that. Okay? Pero no. I want to see in Desmos. Super clear. Okay, look, example. Okay, this is the parabola. Look, parabola. And this is the new one after the transformation. Let's do the transformation one by one. Suppose eliminate 3, not 3. Suppose eliminate the negative. Okay, so the first transformation was a horizontal shift 5 units to the right. And when you apply the negative, a reflection, and when you apply +3, is vertical shift 3 units up. It's up because 3 is positive. When there's negative inside the parenthesis, it's to the right. Okay. Any question, guys? It's super easy or super confusing? Easy, of course, easy. Okay, this was example 2, no? Let me try example 3. Okay, bring me a new problem. Oh, no, it's easy also. Example 3 is, let me go to the whiteboard. Switch it to the whiteboard. Okay, example 3 now. Okay, whiteboard now. Let me erase the board because too much information. Okay, good. Example 3 now. Example 3 is a function, let me call h of x equal x minus 1 cubic, 1 cubic plus 7. And I need help. Help me, please. Help me. Please. Okay, look at that. Number one is identification. And what family belong this? Remember, we have a library of the function. In the library of the function, we have collection of the function. And you need to identification and what family belong this new problem. Entonces, what do you think? What do you suppose? Or what family? Remember, we have a cubic function, of course. This belong to the family of the cubic function. Okay, by the way, cubic, Andreina is a cubic. I remember que it look like that. Wow. This is X, this is Y. Now, the second and the third step is identification. What kind of transformation we have? To the right, very well. So, a line say this X minus 1 is horizontal shift 1 unit to the right because it's negative. And finally, plus 7 is vertical shift 7 unit up. Okay? 7 up, like a soda. 7 up. Okay, let me see in decimals to understand the idea. Okay, here. Okay, there you go. Well, this is my famous cubic function. Oof, wait. This is my famous cubic function. And this is the new one after the transformation that we have. Let me see. Step 1 is, suppose I delete that 7. No 7 anymore. Entonces es obvio que es horizontal shift 1 unit to the right. Okay, super, because it's minus. Plus 7 is 7 up. Plus 7 is 7 up. 7 up. Point by point, any point goes up. 7 units. Any question, guys? Any question? Okay, let me try. Okay, this was, in my opinion, the easy example. Let me complicate a little bit more. Suppose example 4. Example 4. Example 4. Let me go to the whiteboard. And let me try to discuss in example 4. And example 4 bring me new situation. What new situation? Is a situation in which it's not clear, it's confusing, the transformation. Suppose example 4. And example 4, suppose the function, I don't know, f of x equal square root 5 minus x. Okay, this is a typical example in which you don't see clear the transformation because, okay, listen to it. Identification what family is easy. Is f of x equal square root. This is a square root function. And a square root function look like that, the graph. Remember, square root function contains only one branch because the domain is only positive number and includes 0, no negative. Entonces now I know, okay, entonces I see this minus. Entonces this minus, when it's like that, minus x. This is reflection. Entonces reflection is like that. Perfect reflection. No, I did no well. Like that. Okay, this is the graph of the radical x basic function, and this is the graph of the radical minus x. This is a reflection. Some reflection happen, but I don't know exactly. And phi. Phi is positive, phi is positive. Entonces, maybe it's inside the parenthesis like that. But this is horizontal shift, but in what direction? Is to the right or to the left? This is the problem, right? To the left, to the left. Right or left? Some people, Frank believe que es to the left. Okay, Frank. Entonces, in this example, que I bring intentionally, of course, is no elementary to understand que right or left, because we need to do some transformation, some algebraic transformation to understand the transformation. So you need to modify a little bit. Okay, so I propose this idea, que es classical, no? It's always when you have a radical. Suppose que you factor out one negative. It's a negative one here. So we have x minus 5. Do you see that this expression and this expression are equivalent? This expression, and let me try. Entonces, negative and positive is negative, and negative is positive, like that. Okay, now, I suppose que it's a little bit more clear the transformation. According to the order of operation, this minus represents reflection. Okay, we are doing something. And now, okay, reflection, number one, reflection about y axis, because it's negative. And now we have in number 3, we have horizontal shift. But in what direction? Right or left? Right or left? It's all because right, no? Because it's negative. No, align. It's right. Because it's negative. Okay? Entonces now, okay, after the modification, and the original you don't see very well. No, it's okay, align. Okay, and the original is confusing. So I bring this example to illustrate que not always is evident, que not always is, que sometimes it's confusing, the transformation. You need to manipulate a little bit algebraically our original expression to understand, to see more clear the transformation. Horizontal shift 5 unit to the right, because it's negative. Okay, just in case, don't frustrate, because I put in decimals. In decimal, give me the true. Give me the true always. Okay, I go to decimals because I am confusing, very confusing, very confusing. Okay, no problem. However, I have the decimals, que es our free, beautiful graphic calculator. Look. This is the right square root. No. This is a square root. Okay. Sorry, you see decimal or not yet? Do you see or not? Sorry, good, very good. Thank you, Andrea. Okay, look. And the graph of the given function is like that. Boom. Do you see in blue color? Wow, what the hell? Okay, sorry. I don't know what happened. Carajo. Okay. You still in decimals? Okay. In blue color, do you see the transformation? And this, I suppose, is algebraically equivalent, no? Let me show you. In green color. And the green and the blue is the same. Look. More clear now? So I bring this example. I bring this example to illustrate que no always is easy. I bring another more complicated. I bring another more complicated. Let me go back to the, let me see. Number 5 example. Number 5 example is very interesting. Number 5 example. Example 5, let me copy here. Example 5 in my paper is y equal x squared minus 4x plus 5. Okay, let me try. I go to the whiteboard to explain that. Okay, switching to the whiteboard, please. Whiteboard. By the way, guys, we are recording the lecture or no? Let me see. Yes. So fantastic today I have. Record the lecture. Thank you. Okay. No, well, I don't do that. Okay. Okay, I'm a little bit crazy. I don't remember. Okay, number 5. Number 5 example is another example in which you need to do something algebra to understand the transformation because it's confusing, it's not clear. Example 5 is f of x is equal x squared minus 4x plus 5. Plus 5. Also, plus 5. Ok, entonces, number 1, identification what family belong, es obvio que es the function x squared. Ok, entonces, then, this is a parabola, but this is also parabola. Belong to the same family. I don't know si es like that or es like that, reflection, I don't know exactly. Pero es parabola. Entonces, to see the transformation, I have no idea. It's not clear, it's confusing, very confusing. Why is very confusing? Because you need to manipulate this equation to understand the transformation. So this is a classical example in which you apply complete square one more time. Complete square. One more time. So remember complete square is y equal x squared minus 4x. And complete square is the classical formula in which you take b, que 4, I don't care the sign, divided by 2, and a square. Entonces, 4 divided by 2 is 2 to a square 4. It's a coincidence que es 4. Entonces, the magic number that we need to complete the square is 4. But unfortunately, we have 5, not 4. But it's okay. I can split 5 like a 4 and 1. So this is equivalent, no? Now, this trinomial is perfect square. And the factorization is pretty easy. It's x minus 2 squared plus 1. Wow. And so we focus in this new expression that, by the way, is equivalent algebraically to the original. But in the original, I have no idea what transformation it is. However, I am super easy. I can see that we have number 1, horizontal shift 2 units to the right because it's negative. And finally, we have vertical shift 1 unit in the story. Okay? But just in case, I want to verification in Desmos to see if I understand or not very well. Everyone follow me? Follow me or not? Confusing? Yes. I like this class. I like this class. Is the best class I have. Okay. Look at that. This is my parabola. Boo. This is my parabola. Okay, the original, the basic parabola. This is the graph of the given parabola. After the transformation, you see is a horizontal shift 2 units to the right and 1 unit up. And this is exactly the same expression, but after the completed square, you see the red one and the blue one is the same. Okay, but in the blue one, I can see more clear the transformation, and the red one is confusing. Any question? Any question? No, France, no, professor, I understand very well everything. Okay. Let me try to complicate more your life. Okay, because when you see the problem they put in the test, you see, wow, this is super easy for us. Okay, let me try now because in Alex, sometimes we have a complicated problem of the transformation like that, similar to this. Okay, let me erase the board. Let me try to do my best. Suppose one problem in which we have no. Okay, let me see if you see this or not. I have in my computer, okay, one elegant rectangular coordinate system. Sometimes when they're using this, some students say that don't see very well. Do you see this or not? Or you see the white, the black box? Do you see this or not? Yes, okay. I don't know what happened in another class case. I don't see that. So for example, is given that graph. Let me see. 0, 0. -2, -4, -2, -4, 1 point here. And -4, 0, 1 point here. Suppose that one graph is given. Look like a triangle. And this is my original function. Yeah, I need to do the graph of the new one after this transformation. G negative x minus 1. Oof. What the hell is that? Okay. Who helped me to understand this? How many transformations you can see in this expression? How many? Okay, this is the point. How many? Two transformations. You can identification. Which one? I need the name. Two transformations. Okay, Andreina. Andreina is a two transformation. What kind? That point is the point. -2, -4. -2, -4. The first one is reflection. Very well. What kind? What kind of reflection? What kind? And vertical shift. Vertical shift. In what direction? Vertical shift. So what's good the answer? To flip horizontal and translation. Okay. What is the order? The order is first of all reflection. No? Reflection. We respect the y-axis. So this minus indicates us. Okay, this is the first one. A reflection. This is super easy because the only thing you should do is change the sign of the x component, no? This is 0, 0. 0, 0 stay the same. Because 0 have no sign. But this is -4. So now it's +4. And this is -2, and it's a +2. Okay, so this point now is 4,0, and this point is 2,4. And the graph after the transformation. 2,4 here. Sorry. Carajo. Okay, here, over there. Okay, this is 4,0. and this is 2,4. And the new graph after the transformation is the blue color. It was typical reflection about the wax. Super. Now, the second transformation is Bergachev. 1 unit down because it's negative. So any graph is going down 1 unit. For example, let me use another color, green color. This point is 0,0. So I focus it in the blue, the black graph was the original. That's the history. I don't touch anymore. I am doing sequentially the transformation. Transformation number 1 and transformation number 2 on the graph of the transformation number 1. At that point, it's going down 1 unit. So this point now is the point 0, -1. At this point is 0, -1. This point is now 4, -1. And this point is 2, this is -4, sorry, carajo. This is negative, it's the same. This point is the point 2, -5. And does my graph look like that? Let me try to do my best. It's the same shade, guy. It's hard for me to manipulate the paint. Let me try it one more time. Okay, well, I have a rule, but no rule. Well, let's do a rule. Okay, rule. Okay, we connected this point and this point. Okay, good, very good. Pero no, it's this point and this point, the green one. Green. Okay, there you go. And the other, no, I don't like the rule. It's complicated, the rule. Okay, stop here. Do you understand or it's confusing? But basically, when you are doing the graph, you take, I recommend 3 reference points, and you translate this reference point. And the rest of the point, I suppose, can suffer exactly the same transformation. Wow, too much. Any question? Any question? Transformation is clear. Don't worry because I go over it again to the transformation and the review package, no? Que soon I will send to you. Any question? No? Okay, guys. So we move on to another important topic, que es a combination of the function. Combination. Combination of functions. How we combine functions in different way. We can use it, for example, at the beginning, the arithmetic operation, addition, subtraction, multiplication, and division. So suppose the notation is, suppose f plus g of x. This is equivalent to say f of x plus g of x. It's a combination. We have two original function, f and g. We put together using plus, using addition. And this is the new function, because the notation is f plus g. Likewise, f minus g is equal f of x minus g of x. This is, in this case, subtraction. Subtrahem and minus m. Subtraction. Now, why not multiplication and division? Multiplication is, the notation is f times g of x is equal to f of x times g of x. It's a multiplication. Multiply. And divide is f division by g of x is equivalent to, say, f of x divided by g of x. Division. Okay? This is the easy part. However, what's the complicated part? The complicated part can normally, when in the test, you can see problems similar to this problem of the combination. I ask you two things. The first one is, what is the final expression? This is the easy part. And the complicated part is the domain. So, because when you combine two functions, what is the new domain of the combination? Well, okay. And this is always the same. The domain is equal domain of f and domain of g. Okay? See, we're using the symbol way in the set theory is domain of f intersection domain of g. So that's the part in which the both domain share. We have overlap. And the division a little bit more complicated because it's domain of f intersection domain of g, and it's an intersection when the g is not positive. No zero, sorry. Because you know it's totally illegal division by zero. Okay? Let's see example. It's no big deal, it's super easy to understand that part of the combination. Suppose that it's given two functions. Suppose the first one is 1 over x plus 3. And suppose g is x over x plus 2. Entonces, en the test, I ask you only one, no the four, but let's do in, I don't know, one couple of the combination, no? Suppose I want f plus g of x. Bueno, entonces addition 1 over x plus 3 plus x over x plus 2. And leave it like that? No. You're condensing this and this in only one, no? So es least common denominator is both, no? Es x plus 3 and x plus 2, no? So es paréntesis x plus 3, x plus 2, and the top we have this multiplied by 1, or not multiplied by 1, this divided by this times 1 is x plus 2 plus x times x plus 3. Leave it like that, no? The rest is easy, elementary algebra. We remove the parentheses and the top, of course. This is x plus 2 plus x squared plus 3x. X plus 3, x plus 2. Well, you organize and combine later. This is x squared plus 4x plus 2, no? Divided by x plus 3 and x plus 2. Okay, this is the new expression que represent the combination of the two given original functions. However, what about domain? Well, domain is easy in this case because domain of f, looking for f. Domain of f is all real number except -3. So it's all real number except -3, x equal -3. So in other words, x no equal -3. So in -3, basically, we have a whole. And domain of G is all real number again except -2. No -2. Entonces, what is the answer? Leave it like that? No. Why not? Because normally in the test, I asked you to express a domain using interval notation. Interval notation. Entonces, interval notation, remember, guys, the mnemonic device to do that is recommend doing the graphic. Okay, this is my famous Orion number line. I identify that we have two holes. We have a hole in -2 and -3, -1, -2, and -3. We have a hole here in -2, and we have another hole in -3. And the rest is okay. So what is okay? Okay is from -infinity to -3, from -3 to positive -2, from -2 to positive 3. That's the conclusion. Domain of the function, okay, remember the name is f plus g, is parenthesis -infinity, -3, union, -3, -2, union, -2, infinity. And the story. Do you understand very well this or no? Let me try now to explain one problem of the division. Okay, division bring me new situation. Division bring me new situation. Division is a little bit different. Division is suppose exactly the same function, but I ask you in the test, f division by g of x, expression and domain. Okay, let's do it. F is 1 over x plus 3. G is x over x plus 2. So we have now division to complex expression. So you copy the top, exactly the same. Flip at the bottom. Okay, so my expression look like that. X plus 2 in the top, and the bottom is x times x plus 3. I'll leave it like that. Why not? Why not? And what about domain? Well, domain is wow. It's a little bit different. Domain is no zero. Look, because 0 here, and not and no -3. Look here, because -3 plus 3 is 0, entonces division by 0. Okay, so now I want you leave it like that. You can leave it like that, but on the test, no. In the test, you need to express the idea using, again, one more time, the interval notation. Infinity, -infinity, we have two hole. In 0, we have a hole. In -3, 1, 2, and 3, we have a hole. Okay, entonces en blue color, this is that part, this is that part, and this is that part. Entonces from -infinity, -3, union -3, 0, union 0, infinity. And this is the domain of the function f division g. Any question? Any question? No? Okay. Okay. Another way, more complicated, are you tired, guys? Are you tired? No. You take a breakfast? Good breakfast or no? Another, No, okay, super. Another way. Okay. Another way to combine. Okay. Let me try. No, another way. So let me try another example. Suppose two functions. Suppose s of x equal x minus 6. And suppose t of x two new functions, que es 2x plus 5. They want to know the new function s times t of x multiplication, x minus t subtraction, and x plus t addition of x. And remember, new expression and domain. Remember, new expression and domain. Okay? Let's do it. Let's do it. Bueno, es easy, ¿no? Expression multiplication. Entonces, x minus 6 times 2x plus 5. And leave it like that. No. You foil, no? You foil. This is 2x squared. This is 5x. This is minus 12. And this is minus 30. Now we combine. 5 positive, now minus 12 is negative 7. Entonces, the new expression is 2x squared minus 7x minus 30. This is the new expression que represent the multiplication, is the combination to function, no? And what about domain? What about domain? Okay, what is the domain? This is important thing. This is confusing thing for the student. Domain of S is all real number. Why? How do you know? Remember the agreed mean. Agreed mean is when you want to determine the domain of any function, you assume que it's all real number except the restriction. But we have no restriction because this is linear function. Remember, we have restriction when you have division, when you have radical, and the top and the bottom. You remember the three restrictions, esto de 1, 2, 3. Division, radical in the top, or radical in the bottom. No, this is because it's all real number. And this is exactly the same, it's linear function. Domain of t is all real number. Therefore, the domain of this new one is all real number also. Because of the intersection of. Okay, subtraction. Subtraction is easy because it's x minus 6 minus 2x plus 5. Is x minus 6 minus 2x minus 5. Is minus x minus 11, no? And the domain is again all real number. It's a nice because they are function linear. And addition, same thing. X minus 6 plus 2x plus 5. So it's 3x minus 1 because negative 6 and positive 5. And the domain again is all real. Any question, guys? Super easy. Okay. Let me complicate a little bit more this because it's too easy. Let me see composition. Composition. Function composition. Function composition. Okay. Function composition is, again, is one way to put together, combine two functions. Suppose que two function is given. F of x is given. Is x squared plus x plus 1. And g is also given. Is 2x plus 3. I want to form a composition. And the notation, the special notation that we are using to composition is F composition G of x. This is 0, like a 0. What does mean that we have two functions. And the ordering is important, extremely important. G is the first one. What is the reason it's the first one? Because it's close to x. Remember, x represents the value of the domain. Now you plug it in first in G, and after plugging in F. So in other words, this is another way to represent the same idea using order of operation, no? Parenthesis first, you plug it in G, and after you plug in the answer of this in F. Mm-hmm. Suppose I want to express it the new expression que represent the composition. And guys, it's completely different. So the composition is no commutative. No, we cannot do it that way. So we can, but it's different answer. So when you are doing in this order, don't expect que this expression or this numerical value is equal to this. No, it's completely different. So in general, in particular, yes, you see throughout the course another example que satisfy this condition, but in general, F composition G is not equal G composition F. No. In general, no. In particular example, yes. You see, no this chapter, the chapter. Okay, entonces now let's do a composition, a new expression, que es easy. Suppose que we are doing this first. Let's do it in both. Entonces G first, que G is this. Go inside this. But inside, and that, and that. So in other words, in order to find F composition G, you replace in the outer function, que es F, G. Replace X for the entire G. So it's 2x plus 3 square plus 2x plus 3. No square because the power here is 1. This is 1 plus 1. Leave it like that, no? I need to do something here. You FOIL 2x plus 3 times 2x plus 3 is 4x squared plus 6x plus 6x again plus 9, no? Because it's 3 times 3 plus 2x plus 3 to power 1, is like that, plus 1. And finally, we combine like that, 4x squared. We have this, and this together, que es 14. 14, 12 plus 2, 14. 14, plus 13, no? Because 9 plus 3 is 12 plus 1, 13. Okay, this is expression F, G, composition X. Composition. Let's do it in opposite direction. In opposite direction is, suppose I want to do in green color, G composition F of X. It's a completely different idea. I suppose it's easier because F go, entire F go inside G in this order. You replace X for no X anymore, F. So 2 times X squared plus X plus 1 plus 3. This 3 is this 3. This 2 is this 2. And you replace X for the entire F of X. And the rest is easy. The rest is distribute the property to eliminate the parentheses. And we combine like term. And that's it. And this is my G composition F. New expression. Is confusing or is clear, the composition? No, I bring more example, of course. I bring more example. Suppose this example typical. Okay, normally we can do that using variable, or we can use a numerical value, no? Suppose this. Suppose U of X is equal X squared plus 9. And W of X is square root X plus 8. Yeah, I need to compute U composition W, evaluate in 8. So in this case, in the previous example, I am doing using X. It's arbitrary value. In this case, no, it's numerical value. So basically, the interpretation of this is U is the outermost function, W is the close. So you evaluate W and A. Sorry. Okay, so we computed, for example, W and A, W and A, here in the corner of the paper, W and A. W is this, no? So basically, it's the square root A plus A. A plus A is 16, and the square root 16 is 4. And this 4 substitution here. So U evaluating 4. Because I discovered that W and A is 4, no? Now you evaluate U4. So when you evaluate U and 4, is 4 here, is 4 squared plus 9, no? 4 squared is 16, and 16 plus 9 is 25. And the answer is 25. This is another way that you can see in the test, and you can see in Alex. Suppose in opposite direction. Suppose que W composition U, evaluating A again. Entonces W bracket U and A. Let's do it. Entonces you compute first U and 8. U and A is, well, substitution A here. A squared plus 9. A squared is 64. And 64 plus 9 is 73. Actually, W bracket 73. Now, W evaluating 73 is square root. Remember the W function expression is square root x plus A, pero A now, x now is 73. 73 plus A is 81. And the square root of 81 is 9. And it's the final answer. Okay. Listen. What is the final answer? The final answer is U composition W evaluating A. The answer was 25. And W composition U in A is equal 9. So we expect when you're switching the order of the function, don't expect that we get the same answer. No. Don't expect. Okay, but it's not enough. Okay, this is clear or confusing? Okay, basically, see, I try to explain in easy way, on easy words, what is the idea behind the composite function is we have two functions, but one function go inside another function. Okay? It's a composition, it's sequentially. Okay. Guys, are you too quiet? Do you follow me or you are lost? Yeah? Randy, do you follow me? Sabrina, clear. Okay. Lusting, is it clear? Okay. I need to know, guys. I need to know. Okay. Let me try to explain another possibility to ask this question of the composition. Okay, you can see maybe in Alex. Okay, suppose that the function is given but in a different way, using this arrow diagram, composite function. For example, one function is given like that, using arrow diagram. Okay, this is 1, this is 3, this is 4, and this is 5. This is the domain of the one function is f. And the range of the function is 0, 6, and 9. And the association is 1 is associated with the 6. So this line contains arrow because it's the one direction, domain and range. 3 or 9. 4 with 6 is possible. Remember que es possible. Many to 1 is possible. And 5 with 0. Okay, wow. Okay, this is the function f. Function f. And also, I have another function that is g. I want to form a decomposition. Okay, this is domain of G. This is the range of G. Entonces we have 4. We have 6. We have 9. We have 2. And we have 6. Entonces the combination of 4 and 6 is associated. This information is given. I suppose you don't know. It's given. You're using that. This and this. And this and this. And this is the function G. Okay. See, I summarize domain of F is 1, 3, 4, and 5. No specification interval notation because this is a discrete value, not continuous. And range of F is 0, 6, and 9. Likewise, domain of G is 4, 6, 9, and range of G is 2 and 6. Okay. Okay, now I want to compute. I want to compute G composition F. Evaluating 1. Okay. We have several questions, no? 1, 2, 3, 4 questions. Okay. Okay. According to this order, the order is you evaluate first in F and 1. So in 1 here in the domain, the answer is 6. So G evaluating 6. And G evaluating 6, the answer is 2. Do you follow me, guy? Do you follow me? Do you follow me? Okay, okay. Yeah, okay. Super. Now suppose G composition F evaluating 3. This is G, and the first function is F in that case, exactly the same. But G and 3 is 3, and 9. And 9. And G and 9 is 2. Is 2. Everyone follow me? One more. G composition F evaluating 4. Okay, align. He said yes. Okay, G bracket F evaluating 4. F evaluating 4 is 6. And 6 and G is 2. Wow. So everything is 2, 2, 2. Wow. This was a problem taken with the Alex. Evaluating 5. Is G bracket F and 5. F and 5 is, let me see, 5. 5 is 0. And G is 0. Oh, we have no here. We have no 0. We have no 0 is undefined. Undefined. Because 0 is the value here, but don't have 0 in the domain of G. Therefore, the answer is undefined. Entonces, complementa the question. What is the domain of the composition? Let me try. Domain of the composition, actually, the thing that we are doing is the composition, this function and this function. Okay, therefore, you intersecting this and this. So the range of F and domain of G have the same values. It's not the same. Entonces, this number, like a phi, is totally undefined. So in order to find the domain of the composition, you take this set and this set and this order, and you form the intersection. So intersection is, let me see. Okay. Let me try to do the sketch to understand this. We have here intersection and intersection. You put together this and this. So this, we are forming now the intersection. The common value here and between the range of F and domain of G is 6 and 9. It's obvious that 0 and 4 disappear because 0 and 4 have no common here. When you form the intersection, only stay 6 and 9. Okay. And 1 is associated with the 6. Okay, good. It's a 1. It's associated with the 6. 3 is associated with the 9. And 4 is associated with the 6 again. And 5 is associated with the 0, but 0 disappear because 0 is not common in the second function. Okay? Okay. And then here we have 2 and 6. But 6 is associated with the 2. And 9 is associated also with the 2. And 0 and 6, sorry, is associated with nothing. Now, what is the domain of the new function after the composition? What is the domain? Domain of G composition or G composition F. Remember, I assume that G is the first function. F is the first function, sorry. Okay, this diagram is equivalent to that. 1, 2, 3. 1, 2, 1, 3, 4, sorry. And this is just 2. So 1 somehow is connected with the 2. Look. 3 is also connected with the 2. And 4 is also connected with the 2. Okay, domain is 1, 2, 3, 4. 1, 3, 4. And the range of G composition F is just 2. And the rest is intermediate value. Okay, you pass through this, but no necessarily. This is domain, and this is range. This is confusing, eh? A little bit or no? Confusing or no? Kind of, yes. Okay, the most important is when you are doing this problem, okay, I suppose you were doing in ALEC, not in my test. You intersecting this and this. You try to find the common part here. And you copy here. And after you following the rule, some number is undefined because don't matching to the intersecting. And the rest que don't matching is because nobody selected. So you, little by little, you modification this diagram like that and like that. And you have the domain and you have the range. Okay. Let's see the same idea, but not using that diagram that you don't like. Using the function, using the function. Using the function. Let me try. using the equation, using the expression of the composition. Look, this is another typical example in which two functions is given. Suppose this 1 over 3x squared plus 2, semicolon, and g is square root 5x plus 4. No. This not because this is not composition. Let's continue with the composition and that's it. No, this no. Okay, guys, no more composition. After in the review, we go over composition to understand much better this. Okay, so let me go to the symmetry. Symmetry is extremely important. It's extremely important because we have to analyze next in the next chapter in the test 2. We need to analyze the graph of the complicated functions and try to find some. And okay, got it. And what is the idea for the symmetry? The idea for the symmetry is, look, suppose you have function and you make a reflection. But what kind of reflection? For example, you replace x for negative x. You know that when you are doing that reflection, it's a reflection about the y-axis. Suppose we have a function like that, the graph looks like that. When you are doing the reflection, the new graph is like that. Okay, this is the idea, reflection. When this situation happens, when you are doing reflection and the function stay the same, magically stay the same, nothing changed. It's because the function is even function. And the even function have a special symmetry with respect to the y-axis. Typical, super typical example is the parabola. Suppose f of x equal x squared. When you replace x for negative x, let's see what happens. This is negative 1 raised to the second power, and this is x to the second power. And negative 1 squared positive 1. And we compare this and this, it stays the same. Therefore, it's even function. And it's extremely logical que it's even function because the parabola look like that. And when you are doing reflection, this branch and this branch stay the same. Okay? But another more complicated example, no. Entonces we take advantage. See, you when you are doing the graph, what is important to understand symmetry? Because when you are doing the graph of the complicated function in the next chapter, and we discover que es symmetric, symmetry, es even function. So in order to do the graph, you know that the positive part and the negative part is exactly the same. And you care about the positive part because I know that the negative part is exactly the same, it's symmetric. So you take, you evaluate 2, you evaluate 3, you evaluate 4, because I know that negative 2 and negative 3 and negative 4 is the same value. This is the importance of the symmetry. This is not the only symmetry we studied today, no? This is symmetry que es even function. Example. Suppose one function like that. F of x is equal 3x squared plus x to the 6th power plus absolute value x. Entonces, in this test, I ask you, determine algebraically whether the given function are even or not. Okay? So the professor explained, I replace x for negative x. Actually, the thing we are doing is reflection. Reflection about the y-axis. Oh, but I know when the exponent is even, it stays the same. Yeah, I know the actual value of negative number is equal positive actual value. And we get this answer is exactly the same of the original. Therefore, we prove algebraically that this is even function. Super. Clear or confusing? It's clear. Okay. This is the only one kind of the no. We have odd. We have odd function. What is the idea? Symmetry again, symmetry. But another kind of symmetry is odd function. Okay, super. Safra. Odd function is look. When you replace, we're doing exactly the same transformation, and suddenly happen that no, it's not the same. It's opposite sign. This is typical odd. It's definition. Okay. Suppose to understand this. Suppose that we have something like that. When you replace, this is x, and we have f of x, guess y. Now, when you replace, let me use another color. Minus x, que es opposite direction, minus x. We have exactly the same magnitude of this, but negative, opposite direction. So this segment and this segment is the same. The same in actual value, but it's opposite direction. When this situation happens, this is odd function. Okay, what are the typical example of the cubic function? For example, suppose f of x equal x to the cubic power. You are doing reflection, always it's the same reflection. It's a negative x to the cubic power. But this is negative x, negative 1 to the cubic power and cubic power. No? And negative 1 to the cubic power is negative 1. And when you compare this guy and this guy, is opposite sign. Therefore, this is odd function. Okay, so otherwise, so let me summarize the idea of the symmetry. The symmetry, we have two kinds of symmetry, number 1 and number 2. When you are doing this reflection, the function, wow, stays the same. Nothing changed, it's even. When you change x for negative x, and this is opposite sign, it's odd. Otherwise, it's neither. Because it's no even nor odd. Okay? And this is a special cases, important cases, and this is totally ordinary case. Okay? Entonces, when you prove in the next chapter the symmetry, si es even, well, si you prove somehow que my function is even, look, the typical even, you have a function, and this is symmetric, perfect symmetry. Entonces, okay, you prove this, it's because one value of the x give me one value of the y here. And in the same opposite direction, minus x give me exactly the same y value. So I care only the positive part because I know that the negative part is the same. Okay, however, it's odd. It's a different situation. Suppose you have that situation. When you try to evaluate x, you get one value of the y. When you evaluate a minus x, let me use in green color, minus x, you have exactly the same, but minus y in opposite direction. This is, well, this is symmetry with respect the y-axis, symmetry with respect y-axis, and the name of this is symmetry also, symmetry with respect the origin. I suppose que the origin, because it's, look, this is the origin 0,0, and this distance, and this distance is the same. It's somehow symmetry with respect to the origin. Otherwise, it's completely crazy function, no special, ordinary. Entonces yo suppose que it's something like that. We have to function like that, and another is completely crazy. This is neither. Because in the neither, it's obvious que the negative part and the positive part, they have no relationship. It's completely different. And you need to plot separately positive part and negative part. This is important to do the... Okay, guys. Let me stop here because it's too much for one day, no? Of course, we don't finish. We need to explain one elementary thing, but I want to explain using the inside the review package. I say, as soon as possible, no. See, we go over to review package, right? Okay, any question? No? Okay. So stop, take a break, because I have another class now. Okay, it's complicated class, not like this class is nice. Wow, everyone understand very well everything. I love you, this class. Okay. Thank you. Bye. Have a nice day.
Oh.